What is thermal efficiency of thermodynamics engines? Have you ever wondered how effective a heat engine really is at turning heat into work? The answer lies in the concept of thermal efficiency. This term describes how well a heat engine converts the heat energy it receives into useful work. Thermal efficiency is defined as the ratio of work output to heat input. To put it simply, it tells us how much of the heat energy is transformed into work instead of being wasted. This ratio is usually expressed as a percentage. In a typical heat engine, heat energy is taken from a high-temperature source. The engine then performs useful work, like moving a piston or turning a turbine, and finally releases some heat to a lower-temperature sink. Due to the laws of thermodynamics, specifically the first and second laws, it is impossible for an engine to convert all input heat into work. Some energy is always lost as waste heat to the environment. Mathematically, we can express thermal efficiency with a simple formula. It is calculated as the work output divided by the heat input. Alternatively, it can also be represented as the difference between heat input and heat rejected, divided by the heat input. This means thermal efficiency can range from 0% to 100%. However, in real engines, it is always less than 100% due to unavoidable energy losses. These losses can come from friction, heat loss, and other inefficiencies in the engine cycle. For practical heat engines, such as internal combustion engines or steam turbines, thermal efficiencies often fall below 50%. For example, a gasoline car engine typically has an efficiency around 25%. This illustrates the challenge of efficiently converting thermal energy into mechanical work. Understanding thermal efficiency is essential when looking at thermodynamic systems and cycles. It helps us evaluate and compare the performance of different heat engines and refrigerators. Improving thermal efficiency means achieving more work output for the same amount of heat input. This is vital for energy conservation and reducing fuel consumption. In essence, thermal efficiency measures how effectively a thermodynamic engine converts heat energy into useful work. It is always less than 100% due to physical limitations. This concept is key in designing and assessing heat engines and related systems.